What will be the answer? Uh,
Uh, Either it could be, I mean,
16.
yeah,
Okay.
18, right? No, 16. It's in circle, right?
Huh.
Okay, it will be 16. So let me try to understand this question first.
Hmm.
So I will. It's like a ring
Hmm.
where you cannot pick two adjacent candies, and you have to pick the candies such that the answer will be maximized,
Hmm.
right?
Hmm.
So if in this example, 2, 4, 6, 8, and 10. One possible outcome would be I would have chosen 2. If I have chosen 2, I could not choose 4 and 10 because they are adjacent. And then I might have chosen 6.
Hmm.
So the answer would have been 8.
Hmm.
Other possibility would have been I haven't chosen 4 and 8. The answer would have been 12.
Okay.
Then I would have been chosen 6. Then yeah,
I can
answer
choose
should
either
have
2
been
or 10.
yeah, yeah. Uh, Okay, so let's say we just have 2. The answer would have been 2.
Hmm.
Now, so this is my array and this is my output. Uh, OP just right. So my array consists of only one element. That will be the answer. Now I have two elements, 2
Hmm.
and 4. The answer could have been either 2 or either 4. I will just choose the maximum one, which is 4. Now I have 6. I have array of size 3.
Hmm.
Now I can either choose 6. If I'm choosing 6, I cannot choose 4. I have to choose something from the previous array.
Hmm.
So if I'm choosing 6, my answer will be 6 plus whatever is the maximum up till 2, which is 2. So 2 plus 6 is 8. But since it is a circular one, I cannot include I cannot include 2 here. Okay, so for simplicity, let's just assume it's a linear line. I guess a simple way we can deal with the circular case is just assume two arrays. This is the first one, and this is the second one. So this is the first one, and this is the second one. I will get the maximum using a simple technique, and I will choose the maximum of those two for this array or this array. Whichever one is giving me maximum, I will choose it as my answer.
Okay.
Um, does it sound good?
Yeah, sounds good.
Yeah. So let's say now my this array is linear array because I have broken the last candy. I'm not
Hmm.
considering the last candy anyways. So now here my answer will be 2 plus 6, or I will choose middle one. I mean there are two possibilities. I can choose 6 or
Hmm.
I cannot. If I'm choosing 6, I cannot consider 4. I have to consider the previous array, right?
Hmm.
So the answer will be 6 plus 2, which is 8, or I I mean I can skip it. So what's the maximum value so far? I'll get it here. So my answer will be either 4 or 8. So I will go with 8. Now I have another element which is 8. So here, um, two possibilities again. I can choose this candy or I can skip it. If I'm choosing it, I have to pick the maximum so far. Sorry, skip this and maximum so far from here, 2 or 4. The answer is, I mean, the maximum so far is 4, and 4 plus 8 will give me 12. Okay?
Okay.
And oh, sorry, 12
4
or
plus 12 will
the
give 16.
8.
Huh.
Sorry, six, uh, yeah, I mean, at this point, there are two possibilities. By the way, can you see it when I highlight the particular number?
Yeah, 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 yeah.
Okay. So right now I have this 8. I mean, the new candy is 8. I can either pick this one or skip it. When I'm picking it, the answer will be
Hmm.
8 plus this 4, which is 12.
Hmm.
Or my answer will be I'm skipping this one, so maximum so far, which is 8. So 12 comma 8. I will choose 12 because 12 is the maximum one.
Hmm.
Now the next one was 10. I'm considering it in linear fashion, by the way, and the trick that I mentioned earlier will be used to solve the circular ring problem. Now, in this case, my answer could be either 18 or 12. I will be choosing 18.
Okay.
So, yeah, that will be my approach. It will just be an DP array, which
Hmm.
will DP at index I will be maximum of DP at index I minus 1. I mean, I'm considering so far, I mean, I'm skipping current one.
Hmm.
Or uh, array at index I, I'm considering the current one plus dp at index I minus 2. I'm skipping the adjacent one, and whatever
Hmm.
is the maximum before that, that will be my answer. So
Okay.
yeah, I think this will do the trick, and I will be doing this for two different arrays. One will start from 2 to 8,
Hmm.
and the second one will start from 4 to 10. So I mean, in one array I'm skipping 2, and in another array I'm skipping 10.
Okay.
Why? Because they are connected, right, in the end. So I can either be considering one or no. I won't be considering one.
Hmm.
So in case where I'm considering 2, I cannot
Okay.
consider 10. So
Okay.
so my array will only consist of these parameters, and whatever this is the maximum one I'll get, I will store it. I will repeat the same process for this particular array.
Okay.
So whatever maximum I get for this one, I will compare the first array's maximum and second array's maximum, and whichever one is the maximum, I'll be returning it as my final solution.
That makes sense. But why do you need to array for this?
Not two arrays, but I have to run it two times, right? So that's why I was calling it as a two array. First time I have to get the output for this particular array, and second time I have to get the output for this particular array.
Uh, okay. So, okay. Can you start with the implementation?
Yeah, sure.
Yeah.
I have to return the maximum, right? Max, uh, max. Okay. This is my given array, and let's say I also have the size of that array. Um, okay. Let's just make it simple first. I'll be doing the linear case first, then I will deal with the circular one. I mean, I will tune the code so that it will support the circular one as well. So I'll be having my DP array
Hmm.
of size, let's say n for now. Okay.
Hmm.
So DP at index 0 will be, is it or 0? DP at index 0 will be array at index 0. Uh, because I just have one candy, so that will be the answer anyways.
Hmm.
Then I will say, if I have two candies, dp at index 1 will be math dot maximum of dp at index 0,
Hmm.
or array at index I. And now sorry, array at index 1. Now I will start from 2 is equals to 2 I is less than n I plus plus. I equals to I is less than n I plus plus. I have to also keep track of max, but I'll do it in the last task. For I equals to I is less than n I plus plus, dp at index I is equals to math dot maximum of dp at index I minus 1, or array at index I plus dp at index I minus 2. So I think this will suffice. And in the end, I will be just max is equals to 0. And for integer value in dp, max is equals to math dot maximum of my current max, or the value that I will be getting at that point, and I will be returning the max in the end. So this will be for the time when we have linear, when the last two, first and the last one are not connected, and let's say now they are connected. So
Just a minute.
I
Can we take max as a keyword? Let me check that as well.
uh, I don't get it. I mean, max as keyword in what sense?
Just so this is not a programming question related, but so in every language we have some words that cannot be taken as variable names, right? So I was just
Oh,
wanted to
okay.
make sure.
I think in Java we can consider max as a variable.
अच्छा, ठीक है, that makes sense.
Okay, so will be returning max. So what I can do is I will be having integer. Um, I can repeat this whole process twice, but I would like to, you know, do it in I mean, in more optimized way.
Hmm.
So I'll just say I, no, or rather start and end, start and end. So my DP will be of size end minus start plus one. Let's just call it n. N is equals to n minus start plus 1. My dp will be of size n. Dp at index 0 will be dp at index start. Dp at index, oh, sorry. Dp at index 1 will be maximum of dp at index 0 or dp at index s plus 1. Start plus 1 for 2. It could be dp at index. Okay, nothing wrong here. Index I, array index start plus I, declare index 1, and then this will be the same.
Hmm.
And now I'll be having another int get max. Here I will be having here array, and I will be having the size of the array. So I will be integer a is equals to max can these array.
Hmm.
I will be starting from 0. I will go up till n minus, will it be n minus 1? It will be n minus 2.
Hmm.
Uh, and my b will be max can tease from array. I'll go from 1 up till n minus 1. And I will be returning dot maximum of a comma b. Uh, okay, so I haven't considered the cases when my n is 1 or 2,
Hmm.
but yeah, they can be added as well. I mean, I have considered them here, but I haven't, checked if n is of size 0. So if it is of size 0, I might, get an error at this point. So to avoid it, I'll just say if n
Okay,
is
so you said
equal
you'll
to,
call this function twice, but okay, can we do one thing? Instead of calling this function just once, what we can have is we can have a two-dimensional DP array,
uh,
DP n
okay,
comma n of 2. So DP n0 will represent that you have taken from the first, and DP n2 1 will
yeah,
present that you've taken from the second, right?
yes. Let me just try to, by the way, do you think this approach is right?
Yeah, this approach is right. That is no issues with this.
Okay. So let's just say I have considered 0. I mean, 0 means I have considered zeroth one, and 1 means I haven't considered it, the first index.
Hmm.
So, sorry, this is 0, and this is, or rather, let's just call it considered and not considered, just for the sake of simplicity. So now if I'm considering to consider and non-consider is just considering the zeroth index or not. Okay.
Hmm.
So if I'm considered to maximum will be 2, here the maximum will be 0 because I'm not considering. Now in terms of when I have 4, I cannot consider 2 because it's my neighbor. So the maximum will be okay. So I cannot consider my last index anyway. So it will be 4 here, and here as well it will be 4. Now I have 6. So here, uh, okay. So in consider section, it will be, I cannot consider this one. So 8, and here it will be 6. Here, my 8 at index, yeah. Okay. So it will be 12,
Hmm.
um, or here it will be 8 plus 4, that is 12. Okay, and now when I have 10 here, okay, anyways, I will be calculating for 10, but I won't be including it in the end.
Hmm.
So for 10, I will get 18, and here I will get 10 plus 6, which is 6. In this case, it really doesn't matter, but my output will either be um, maximum up till this point or maximum up till this point. So 12 comma 16. So my answer will be 16.
Okay.
I cannot consider this 18 because it has considered my start as well and end as well. So it takes, so 16 comma 20. The answer is 16.
Hmm. Okay, this makes sense.
Yeah.
Um,
So if we talk about time complexity, it will be of order 2n. But we can just call it n of n, and my space complexity will also be of order n.
mm, okay, makes sense. Okay, one mistake that I can see that you've done.
Okay. Uh,
One second. If it's a 4, you'll send 2. 2 minus 0 plus 3. So 0, 1, 2, 3. नहीं, ठीक है. It's correct. Um, एक minute. What is you've not calculated for um what if s plus 1 is not there?
uh, yeah, I told you earlier that I haven't considered the cases. I can just check it here. So I mean, basically, it will give me an error if my size is 0 or 1 or 2. So I can just handle those cases here, and I can just hard code the values of them, because if the size is 0, I should have to return 1 0. If the value is 1, I have to return that value anyways, and if it is 2, I can either return the left or right part. So that way, if using if else conditions, I can hard code it here. If you want, I can write them here.
Yeah, please do. Please always write the full code.
Okay, if n equal to 0, return 0, n
Return
equal to
0.
yeah, I mean my array is empty, so the maximum will be 0, right?
अच्छा ठीक है हाँ sorry.
Return array at index 0, and if n equal to 2, I'll be returning array at index sorry, dot maximum of array at index 0, array at index 1. So now let's just say what if it's of size 3? Okay, I should have written it here rather than writing it here. Oh, shit. I can just write it down here. So, so right now, let's just say it is less than 0, less than or equal to. So now it will do the trick. So yeah, I think this will be enough. If the size is 0, I'll be returning 0. If I have one element, I'll be returning that. If the size is 2,
Hmm.
um, I will be returning either one of them. Um, so I have to consider one more case: 4, 5, and 6, right?
Hmm.
So in A, I will be having I will be passing. Oh, sorry, just say I have only two elements: 4, 5. For variable A, I will be passing max candies, and I will be passing only 4.
Okay.
So at that time my n will be 0. It should not be array at index 0. It should be s plus sorry yeah at index s. So s is starting point. I have to return the initial value,
Hmm.
and if it is this one, I can either return s or s plus 1. Yeah, now it's okay.
Sure. Okay. Yeah, this looks good. We can move to the next question if you're okay.
Yeah, yeah.